Okay, so today what we're going to do is solve two variable linear equations. Now, again, you probably have done this multiple times in pre-algebra and again in your Algebra 1 course. Today what we're going to do is officially learn how to solve them using elimination, and we'll also learn how to solve these linear equations by graphing. On the quiz next week, I don't care what method you use. I'm not going to say specifically use substitution, use elimination, use graphing. It'll be up to you how you'll find the ordered pair where the two lines intersect. So the official steps here for using elimination, you should always line up your x, y, and your constants. So generally they'll have you put them in standard form. So like x plus y equals that constant. If you need to change the equation and rearrange the order, you can do that first. Now, what we're going to need to do is once they're lined up, we're going to need to try to cancel one of the variables. And again, you can choose which variable to cancel first. It'll just be important that you're writing nice and neatly so you remember which variable you canceled out first, what you solved for first. In order to get them to cancel, they may not be set up to cancel. So we may have to multiply one of the equations or both by a number to make it become the LCM. And then we'll add the equations together and solve for the remaining variable. Once we get the first variable, we plug it back into either original and solve for that second variable. Now, we're going to have two special cases. When both variables cancel out, if the result that is left is a false statement, then you're going to state that it's no solution. If you're left with a true statement, like 0 equals 0, then your answer is all real numbers or infinitely many solutions. When you're doing the web assign tonight, I believe it'll be like a drop-down thing, and you just pick that choice. Either no solution, one solution, or infinitely many. So let's go ahead and try some examples. So the first one, notice this one's nice and pretty. It's lined up, the x's are on top of each other, the y's are, and the constants. And what's even better, my y's have the same number but opposite signs. So all I need to do is add the two equations together. My y's are going to cancel out. I'm left with 3x plus 5x is 8x. 4 plus 2 is 16. And now I'm going to divide both sides by 8. And I get my first part of my order pair, x equals 2. And now to find the y of my solution, I'm going to plug in x into one of the original equations. It doesn't matter which one you choose. That's totally up to you. I'm going to plug it into the first one. So I'm going to take out x, put in the 2, and solve for y. So 3 times 2 is 6, plus 2y equals 4. Subtract the 6. 2y equals negative 2. Divide both sides by 2, and y equals negative 1. Remember, you're entering your answers in WebAssign as ordered pairs. And again, write neatly. Remember which variable you're solving for first. You may not always solve for x first. You may solve for y. And then what also is important is that you, when you plug it back in, you're plugging it into the correct variable. Now, also in the homework, and it may not be at the beginning, they may ask you to classify the solution. And the classifications you're going to give are either the word consistent or inconsistent. When there's an answer to the problem, when you have an answer, you're going to classify it as being consistent. When you get no solution as your answer, then you're going to classify it as being inconsistent. So some of the questions will have a drop down and they're going to say classify it. So if you get an ordered pair, it's consistent. If you don't get an ordered pair, if we get no solution, then it's inconsistent. Let's try the next one. Again, I'm still doing elimination. This one's also nice and pretty for me. Notice my y's are going to cancel out again because I have positive y and negative y. So I'm going to go ahead and add my two equations. I don't need to multiply by anything. The y's cancel out. 2x plus 2x is 4x. 4 plus negative 1 is 3. Divide by 4, and x equals 3/4. We can get fractions for our ordered pairs. That it does work. Now, WebAssign will not want you to turn this into a decimal. So you're going to enter it in as a fraction. So now I'm going to go ahead and plug back in x. Doesn't matter which. I'm going to plug it into the first one again. 2x plus y equals 4. Plug in 3/4. I can simplify diagonally here. The 2 and the 4 cancel. So then now I'm left with 3/2 plus y equals 4. I'm going to change my 4 into a fraction. I'm going to change it into 8/2. And then now I'll subtract 3/2. Because again, WebAssign wants fractions. And then 8 minus 3 is 5/2. So again, you're going to enter this in as the ordered pair 3/4, comma, 5/2. And because I got an answer, this solution is consistent. Now, for my next one, number 3, I got to do some work here. Notice I do not have my x's to have the same number, but one positive, one negative, or my y's. So now I can choose here, do I want to eliminate x or do I want to eliminate y? When I do the elimination method, I always try to eliminate a variable that's going to involve the least amount of work. I don't want to have to multiply both of my equations if I don't have to. So the better variable for me would be to eliminate y, because I can get away with just multiplying my second equation by positive 4, and then my y's will cancel. If I wanted to eliminate x, I would need to change my first equation into a 10x, and then the second one maybe to a negative 10x. One would need to be positive 10, one would be negative 10. So in that case, I'd have to multiply both equations. And as soon as I start multiplying a bunch of stuff, there's a high chance that I may make a careless calculation error. So I'm going to go ahead and multiply my second equation by 4. And this will eliminate the y. So once I multiply here, I get 20x. I'll do it over here to the side. 20x plus 4y equals -4. The most common mistake I see is when students do this elimination, they forget that they need to distribute that number you're multiplying by to all 3 terms in the equation. They always forget about that constant, but don't do that. So now I'm going to rewrite the other one on top. I'm going to add my 2 equations together. Notice my y's cancel. I'm now left with 22x is equal to -11, divide by 22, and x equals -11/22, which will reduce to -1/2. I now need to take that -1/2 and plug it back in for x into one of my equations. And again, it doesn't matter which. I'm going to do it to the first one because it's actually going to get that the 2 will cancel. So 2 times -1/2, I'm plugging it into my first equation. Notice 2 times -1/2 is just going to become -1. I'm now going to move the -1 to the other side. -4y equals -6. Divide both sides by -4. And y equals 6/4, which reduces to 3/2. So my answer here is the ordered pair -1/2 and positive 3/2. Again, because I got a solution, I can classify this as being consistent. They all have an answer so far. Now, also remember, when you're taking this test or this quiz next week, once you get your ordered pair, a way to check your answer is to plug it back in for X and Y. It has to work for both equations. If it doesn't, then you've done something wrong. Let's try the next one. So for number 4, again, I'm going to eliminate Y. But again, if you wanted to eliminate X, you could, but we would need to multiply both of the equations to get the X's to have the same number but opposite signs. So instead, I'm going to eliminate Y again. I'm going to multiply my second equation by positive 3. So this is going to give me 15x minus 3y equals, and I have to do 3 times 17, and it's 51. Let me go ahead and rewrite the first equation right on top of it so I can see everything lined up nice and pretty. I'm now going to add the 2 equations together. My y's cancel out, and I'm left with 17x equals 68. Divide by 17. 68 divided by 17 is 4. I now need to take that 4 and plug it back into one of the originals. I'll go ahead and plug it into the first one. So 2 times 4 plus 3y equals 17. 2 times 4 is 8. Subtract the 8. 3y equals 17 minus 8 is 9. Divide by 3, and y equals 3. And again, my answer is always written as an ordered pair, because if I were to have graphed these 2 equations, my point of intersection is the ordered pair 4, 3. And again, since I got an answer, I'm going to label this as being consistent. So for number 5, this one I've got to do a little bit more work because I can't get away with just multiplying one equation. And again, you can choose which variable to cancel out. I'm going to go ahead and cancel out the y again. I'm going to multiply. I'm going to make them both, one to be 12y and the other one to be negative 12y. So in order to accomplish this, I'm going to multiply this first one by positive 4 and this one by positive 3. So I'm going to go ahead and distribute the 4 to each one of the terms in this equation. I get 20x plus 12y equals 36. Next, I'm going to distribute the 3. I get 6x minus 12y equals 42. I'm now going to add my 2 equations. The y's cancel, and I end up with 26x is equal to 78. Divide by 26, and x equals 3. I now need to find y, so I'm going to plug it back in to one of the originals. And again, it doesn't matter which. I'll go ahead and do the first one. So I'm taking out x, replacing it with 3, and solving for y. So 15 plus 3y equals 9. Subtract 15. 3y equals negative 6. Divide by 3. And y equals negative 2. So the solution, positive 3, negative 2. And again, because I got an answer, it is consistent. Everybody good here? Let's try the next one. For the next one, I'm going to eliminate y. I know I've been eliminating, I'm going to eliminate x first. I've been eliminating y every time, but just to show you, it doesn't matter. And again, if you switch it up, make sure you're writing neatly so you remember what you solved for first. So I'm going to multiply the first equation by 2 and my second equation by -3. Now, if you would have preferred to cancel y, we would have just needed to make one of them a positive 10y and the other one a negative 10y. But let me go ahead and distribute the 2. 6x plus 4y equals 14. Distribute the blue now. Negative 6x minus 15y equals -3. Add my equations. Notice this time the x's cancel. And I'm left with negative 11y is equal to positive 11. Divide by negative 11. And y equals -1. Now, when I go to plug it in, I'm substituting for y this time, not x. And again, choose whichever one you want. It doesn't matter which. So if I choose the first one, 2y equals 7. 3x plus 2 times -1 equals 7. Multiply. Move the 2. 3x equals 9. Divide by 3, and x equals 3. So just be careful when you put in the ordered pair, the x always is written first and then the y. And again, this is still consistent because I got a solution. Let's try number 7. Same thing. Now, what I'm going to do on this next one, so I don't have to work with decimals, I'm going to go ahead and multiply both equations by 100 to clear my decimal. So really what I'm doing is just moving the decimal point on both. So once I did that, I'm now working with 2x minus 5y equals 38. 3x plus 4y equals 104. You don't have to do this. We did this at the beginning of the school year. It just makes it a little bit easier because we're not using calculators. Now, I need to take a look at my 2 equations and decide which one I want to cancel. So for this one, I am going to cancel, let's see, I'm going to cancel y. I just did y before, I'm going to do it again. So in order to do this, I'm going to multiply this one by -3 and then this one by +2. Again, if you would have preferred, actually, I'm going to cancel x here. If you would prefer to cancel y, you would have needed to make one a 20 and a -20. I chose x because the number I'm multiplying by is a little bit smaller, but again, the choice is yours. So when I distribute the -3, I get -6x plus 15y, and then -3 times 38 is positive 114, and this is a -38. And then when I distribute the blue here, I get 6x plus 8y equals 208. And now I'm going to add the 2 equations together. Again, my x's have canceled again, just like on number 7. And 15y plus 8y is 23y. 114 plus 208 is 322. I'm going to divide by 23. And y, it actually goes in evenly 14 times. I now need to plug it back in. Now, You can plug it back into the original decimal ones, but in this particular case, I'm going to go ahead and plug it into the one where I moved the decimal point. It'll be a little bit easier to work with. So I'm going to plug it into the first one where I move the decimal point. So once I plug in y and I multiply it by 5, I get 2x minus 70 equals negative 38. Add the 70. 2x equals negative 38 plus 70 is 32. Divide by 2, and 32 divided by 2 is 16. So again, you write the x first, and then the y. And again, this is consistent. Now, all of the examples up to number 7 have given us one ordered pair, one solution. So these two lines have been intersecting lines, and their intersection is always 1 point. My first special case is going to be number 8. And this is when I try to combine my two equations, and both variables are going to cancel. When I'm left with a false statement, I stop and say no solution. If the both variables cancel and you're left with a true statement, then you're going to say infinitely many solutions. So let's try number 8. This one I don't have to do a whole lot of work to. I'm going to go ahead and multiply my first equation by positive 2. And once I do that, I get 2x minus 4y equals 6. I'm now going to add the two equations together. Notice both the x and the y cancel. And when it cancels, you're left with 0. And then 6 plus 1 is 7. When you're left with a false statement, 0 will never equal 7. This answer is no solution. If it were a true statement, if I would have gotten 7 equals 7 or 0 equals 0, then it would have been infinitely many. And when your answer is no solution, you're also going to classify it as inconsistent. This is the only time it gets the classification of inconsistent, when the answer is no solution. Let me try number 9. Right, number 9, another special case. Again, we need to try to eliminate one of the variables, but when I multiply my first equation by 2, notice what I'm going to end up getting is 12x minus 10y equals 6. And then when I go to add them, both variables again cancel out. So again, I'm left with 0 equals 11. Again, this is false. 0 will never equal 11. So this is no solution. And again, you would classify it as inconsistent. The next two are going to be the second special case where it's all real numbers or infinitely many. So let's try number 10. So again, I need to try to eliminate one of my variables. So I'm going to say, I'm going to try to eliminate y. I'm going to times this by negative 2. So once I distribute it, I get negative 4x plus 2y equals negative 2. Once I add them up, I get 0 equals 0. This is a true statement. So when both variables cancel out, and you're left with a true statement, then you're going to say that it's infinitely many solutions. And again, you're going to pick this from a drop down. Like you'll pick no solution, infinitely many. On an SAT, they might also classify it as all real numbers. Because what this means is it doesn't matter what number you plug in for X and Y, it's always going to give you a true statement. Because if you graph these two lines, they're exactly the same line. One is just scaled up. Let's try number 11. Now, I'm going to go ahead and try to eliminate. And what I'm going to do is I'm going to multiply my first equation by 8. I'll distribute the 8 to each one. And once I do that, this becomes 4x minus y equals -3. Now I can add them up. Notice again, my x's cancel, my y's cancel, and now I'm left again with 0 equals 0. Again, it's a true statement. So this again is infinitely many or all real numbers. The symbol for all real numbers is that, or infinite, so infinitely many solutions. Because they're exactly the same line. Now, also, whenever you get all real numbers or infinitely many, this classification is also consistent because we have an answer. The only time that it's inconsistent is when it's no solution. Now we're going to practice graphing our equations. Now, the problem with graphing is if your answer is a fraction, and if you're not using like graph paper that's got it broken down into fractions, it may be hard to find that point of intersection. So if you ever get an ordered pair that you think is going to be a fraction, like it's in the middle of a box, you can always confirm it algebraically by either using substitution or elimination. But if you're using graph paper and your coordinates are integers, you should be able to find that point of intersection. So here we go, solving the system using graphing. So all we're going to do is graph both equations on the same coordinate plane, and the intersection of those two lines is the solution. If the lines are parallel, meaning they do not intersect, that's when you have no solution. And remember, one thing to remember back from your algebra and your geometry days, that if your equations have the same slope, then they're going to be parallel. So same slope, the lines are parallel. If, when you graph the lines and it turns into the same line, that's when it's all real numbers or infinitely many. So let's try and graph some of these. Now, you can use whatever technique you want to use to graph. You can either find the x and the y intercepts by plugging in zeros, or rearrange the equations into slope-intercept. And that's what I'm going to do. I'm going to go ahead and put both of my equations into y equals mx plus b form. Now, technically what they usually do in Algebra 1 and in the pre-algebra class is this is the method that they teach first. It's usually the longest and most tedious, but this is usually the method they teach first. Then they teach substitution, and then they teach elimination. But let me go ahead and rearrange both equations and get them both into y equals mx plus b form. So 2x minus 3y equals 3. To get y by itself, I'm going to subtract 2x. Negative 3y equals negative 2x plus 3. Divide everything by negative 3. And in y equals mx plus b form, negative 2 divided by negative 3 is positive 2/3. And then positive 3 divided by negative 3 is negative 1. Now, I'm leaving it as a fraction because remember, this number that's right here, that's my slope. And remember, slope is rise over run. So when I go to graph this, my 1 here, this is my y equals mx plus b. B is the y-intercept, my beginning point. So I'm going to go ahead and put my first point on negative 1. And I'll graph this one in blue. And then I'm rising 2 and running 3. So I'm going to go up 2 and to the right 3. I could keep repeating the process and get a super straight line. Luckily for you guys, you're in Notability, so all you have to do is hold down your stylus and it makes a nice straight line. So this is the first equation. I'm going to do exactly the same thing to the second one. Negative 4x plus 6y equals 6. I'm going to add 4x. 6y equals 4x plus 6. Divide everything by 6. Y equals 4 over 6 reduces to 2/3. And 6 divided by 6 is 1. A big clue here, you should recognize that they both have the same slope. This is a clue that they're parallel. This is going to mean that when I'm done, it's no solution. Good? So I'm going to put my first point on 1. I'm going to rise 2 and run 3. And I can keep repeating the process and get a nice straight line. And notice my two lines do not intersect, so this is no solution. So here, no solution. They do not intersect. And again, remember this would be inconsistent. Let's try the next one. Now, if you notice on examples 13 and 14, the first equation is the same on both. So I already rearranged the first one. I don't need to do it again. So my first equation, I'll write it in blue. This is already in y equals mx plus b. I already did the work over here. So now I just need to work on the second one. So the x plus 2y equals 5. I'm going to go ahead and subtract the x. 2y equals negative 1 x plus 5, divide everything by 2, and my equation is y equals negative 1/2 x plus 5 over 2. So I'm going to start at 5 over 2, which is 2.5, and then I'm going to rise 1 and run 2. When it's negative, I'm going to go down 1. So let me go ahead and do the blue one first. Rise 2. Run 3. So this is my first equation. And now the second equation, I'm going to start at 2.5. And I'm going to go down 1 and to the left 2. Down 1 and to the left 2. This should be the order pair. Here, so down 1 and over here. So my point of intersection is this order pair, 3, 1. So it's right here is the point where the two lines intersect. Then for the next one, the first one again is already rearranged. I did it in example number 12. So y equals 2/3 x minus 1. So I can quickly go graph this one. So rise 2, run 3. Connect your points. I'm not Notability, so my line, I can't hold it down and make a straight line here. All right, then I need to rearrange the second equation. Negative 4x plus 6y equals negative 6. I'm going to add 4x. 6y equals 4x minus 6. Divide everything by 6. And y equals 2/3. I can reduce the 4/6 minus 1. And actually, this was the first equation the second equation from number 12. But this time, notice both equations are exactly the same. So when I go to graph this, it would just be right on top of the blue line. So it's exactly the same line. So this answer is infinitely many. Solutions, because it actually rearranged in slope-intercept form to be identical, or you could also classify this as all real numbers. It's exactly the same line.